Today's lesson is on 15.2, which is changing momentum is related to force. So let's imagine this scenario. As you approach an intersection, you can see the light turning amber or yellow. You begin braking softly, and the force of friction created by your brakes slows the vehicle. Your velocity decreases slowly, as does your momentum. So recall the momentum formula. Momentum is equal to mass times velocity. So your body will continue forward slightly. Because your body has its own momentum, you need a force to slow it as well. And that's what the seatbelt does. It provides that restraining force. Because you're taking a longer time to brake, that force will be small. So forces like friction, they can be large or small. So you can brake hard or you can brake gently. So Isaac Newton, he wrote most of the laws about forces. The unit for force is kilogram meters per second squared, which is also called the Newton in his honor. So a capital N for Newton. So impulse. So forces can either act for a short time or a long time. So if you're braking gradually over a longer period of time, that's a small force times a longer period of time. If you brake hard, the car would stop quickly and you would feel a great force. So it's a larger force times a shorter period of time. Either way, the car would go from a certain velocity and therefore momentum to zero velocity when it comes to a complete stop. So the combination of the size of the force and the time during which the force acts, that is called impulse. So impulse, this is the force that changes the momentum, and force is applied over time. So impulses can change momentum either by increasing it or decreasing it. The bigger the impulse is, the bigger the change in momentum will be. All right, so the equation for impulse is force multiplied by time. The impulse, it's measured as kilogram meters per second. The force is measured in kilogram meters per second squared, or Newton. And then the time is measured in seconds. This is just showing here in a chart what happens to impulse when force and time change. So you can see force multiplied by time gives us an impulse. And we can see here the change in velocity or momentum. Let's take a look at this example. A car is hit from behind by an identical car with a force of 50,000 kilogram meters per second squared. Both cars come to a stop within 2 seconds. What impulse was experienced? So remember that these units here, the kilogram per meters per second squared, is also called the Newton. So the force is 50,000 newtons. The time is 2 seconds. And we're trying to figure out the impulse. So we know our formula for impulse is force multiplied by time. So 50,000 multiplied by the 2 seconds gives 100,000 kilogram meter per second. So that is the impulse of the object. Next, we're looking at impulse and force. What happens to the impulse if the force is applied for a longer period of time? So the impulse, or the change in momentum, increases as force is applied over a longer period of time. Impulse also increases if a larger force is applied. So for example, a force of 500 newtons over 2 seconds will have a greater impulse than a force of 50 newtons over 2 seconds. Okay, so greater impulse, the force was greater over 2 seconds. Compare that to a force of 50 newtons for 5 seconds. It'll have a greater impulse than a force of 50 newtons for 2 seconds. All right, so the time changed here. The force was the same, 50 newtons and 50 newtons. compared to 5 seconds and 2 seconds. So you can change momentum by applying a greater force. You can also change momentum by applying a force for a longer period of time. All right, so there is Math Connect questions 1 to 4, which will look at impulse calculations. And then there's also the 15.2 check your understanding questions on page 276.